So let's go ahead and write our algorithm. So first thing first, we need to grab the file name from the user where the Sudoku puzzle resides. So we do that, we ask the user for the input. Then we read the Sudoku puzzle file. Then, if the Sudoku puzzle file is invalid, we show a warning. Otherwise, we say convert loaded Sudoku puzzle file into a matrix. And we'll be talking about matrices, and we are going to be talking about jagged arrays in our later videos. But for now, just know that we're taking this file and converting it into a structure that we can treat as a Sudoku board. Then we print the Sudoku puzzle matrix. And then we solve Sudoku puzzle matrix. And we solve it by using certain strategies that already exist, and we just need to write a program for those strategies. So we're going to initialize a list of strategies. We're going to use a simple markup strategy and a naked pair strategy. And after that, we're going to capture the current state of the Sudoku puzzle file. So basically, by state, we mean the state of the board. So how everything is lined up. And then we're going to capture the next state of the Sudoku puzzle matrix after running through the first strategy in list. The reason is because if we run through a strategy and the state stays the same, that means that the strategy didn't really do much. And if we then do the other strategy and nothing changes, then we know that our strategies are not smart enough to solve this puzzle. The difficulty of the puzzle is much greater than the strategies that we're trying to use. That's why we're trying to capture the next state, right? And then we're saying while Sudoku puzzle matrix is not solved and the current state is not equal to the next state, then we are going to turn our current state into the next state. Because if the current state is equal to the next state, then not much is going on. But if the current state is not equal to the next state, then we know there was a change. And then we're basically incrementing one up. We're saying that the current state now is the next state, and the next state, I say for each strategy and strategies, so I'm basically running through each strategy, and I'm saying that the next state is basically the state of Sudoku puzzle matrix after running through the strategy to see if that puzzle has changed, right? If the strategy had any effect on the Sudoku board. And then moving downwards, we print Sudoku puzzle matrix, and then we print if Sudoku puzzle matrix was solved or not. Now let's actually see how the strategies work. So simple markup strategy. For each row in matrix, and for each column in matrix, we're going to see if the current spot is 0 or current spot's value has length greater than 1. Basically, if it's 0, then nothing has happened in that spot. If the length is greater than 1, that means that it is a possibility, meaning it's not just at one digit. If it's one digit, then that spot has been solved for, and we can just move on to the next one. But if that spot has 0, then nothing has happened there, so we still need to solve for it. And if it has more than, so the length is more than 1, so it's like something like 1, 2, that means that it can either be 1 or 2, so we have to figure out what it is. So in either one of these cases, we say row call possibilities, meaning the possibilities for a row and column, equals to get possibilities for row and column based on the current spot. Then we get the group possibilities. And for the group possibility, we say get possibilities for the group that current spot is in. Then that current spot will equal to the intersection of possibilities for the row call possibilities and group possibilities. Let me show you what I mean. This is a sample Sudoku board. Basically what we're doing is, if we are trying to calculate the possibility for this spot, then we're taking all the rows, right, all the columns rather, and then all the row and then the column that are intersecting in that spot. And then we're getting all the numbers that this spot is in. So they're basically 9 3x3 sections, right? There's the first one, second one, third one, fourth, fifth, sixth, and all the way down to the 9th. But if that, let's say that spot is this one that we're trying to solve for, then it's in this first group. So basically we're getting all the numbers in that group, and then we're getting the intersection of all the numbers in the group and all the numbers that we got for the column and the row. And based on that, we can calculate either the single possibility for the spot or multiple possibilities that the spot can have. That's just one of the strategies that is used for Sudoku. That's a simple markup strategy, and you can look more into it, but that's basically the simple explanation. And now, going back, we can now explore the naked pair strategy. So for this one, we say for each row in matrix and for each column in matrix, if current spot has naked pair in row, then eliminate it. If the current spot has naked pair in column, then eliminate it. If the current spot has naked pair in group, then eliminate it. Those are the strategies, and this is our algorithm that we will be using for our Sudoku solver.